Welcome back to my YouTube channel GrandpaMathematics. Yesterday we have seen the proof of properties of definite integral. Today we will evaluate the integral using the properties of definite integral. We have to evaluate this integral using the properties of definite integral. Here 0 to a f of x dx. This is in the standard form of 0 to a f of x dx. What is the property we can use? 0 to a f of x dx is equal to 0 to a f of a minus x dx. In most of the problems, we will be using this property only. Now use here f of x is cos square x, a is nothing but pi by 2. We have to write 0 to a, 0 to pi by 2, f of pi by 2 minus x. F of x is cos square x. So this equal to integral 0 to pi by 2, f of x is cos square x, f of a minus x is cos of pi by 2 minus x whole square dx. We have used this property. Now this is nothing but cos of pi by 2 minus x is nothing but sin x. So sin x whole square is nothing but sin square x dx. Now add equation 1 and 2. So 1 plus 2 gives 2i is equal to integral 0 to pi by 2 cos square x dx plus integral 0 to pi by 2 sin square x dx. Now you can see the limit of both integrals are same. So we can write 0 to pi by 2 cos square x plus sin square x dx. We know sin square x plus cos square x is 1. So this reduces to 0 to pi by 2 dx. On integrating, we'll get x, put the values, lower limit, upper limit. When you put upper limit pi by 2, minus 0 is equal to pi by 2. That is 2i is equal to pi by 2. This gives the value of I is equal to pi by 4. So this is the answer. To evaluate this integral, again we will be using this property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Here a is nothing but pi by 2, f of x is root sin x by square root of sin x plus square root of cos x. Now we'll use that property. You can write this as 0 to pi by 2 square root of sin of pi by 2 minus x. A is nothing but pi by 2 a minus x. Wherever x is there, we have to replace by a minus x. Here, wherever x is there, we have to replace x by pi by 2 minus x divided by square root of sin of pi by 2 minus x plus square root of cos of pi by 2 minus x dx. Again we know that sin 90 minus x is cos x. So this will be square root of cos x by square root of cos x plus square root of sin x dx. Again add 1 and 2. The denominator of equation 1 and 2 are same. When we add these two, numerator will get root sin x plus root cos x will get cancelled. Again will reduce us to 0 to pi by 2 dx. So since the limits of both integrals are same and the denominator also same, so we can write like this. So this gets simplified to integral 0 to pi by 2 dx. On integrating we'll get x 0 to pi by 2 will become pi by 2. So this gives the value of I is equal to pi by 4. So this is the answer. In this integration, this problem also similar to the earlier one only. Again we will use this property. What will happen? This is equal to integral 0 to pi by 2 sine of pi by 2 minus x power 3 by 2 by sine of pi by 2 minus x power 3 by 2 plus cos of pi by 2 minus x power 3 by 2 dx. Wherever x is there, we have to just replace x by a minus x. So now this becomes sin 90 minus x is cos x power 3 by 2. So this we can write as cos x power 3 by 2 by, again this is cos 3 by 2 x plus sin x power 3 by 2. Now we will add 1 and 2. So 2i is equal to integral 0 to pi by 2 sine of 3 by 2x plus cos of 3 by 2x. Now this gets cancelled. Again we'll get into 0 to pi by 2 dx. On integrating we'll get x. So 2i is equal to pi by 2. So this gives the value of I is equal to pi by 4. This answer. Next problem, fourth one. This is cos x power 5 sin x power 5, again cos x power 5, again we'll use the property, then this will become cos of pi by 2 minus x power 5. This will be power 5, again this also power 5. Then cos 90 minus x is sin x, This is cos x power pi. This is sin x power pi. Again adding 1 and 2 we get this is cos x, okay. Cos x power 5, this is sin x power 5, then cos x power 5, sin x power 5, we'll get the same answer again. Again is pi by 4. So here we have to evaluate this integral in the modulus of x plus 2 dx, and x varies from minus 5 to plus 5. So we have to remove the modulus and we have to write this as sum of two integrals. If we take x plus 2 is equal to 0, this gives x is equal to minus 2. Therefore, we can write this as integral I is equal to minus 5 to minus 2 modulus of x plus 2 dx plus minus 2 to 5 modulus of x plus 2 dx. Which property used here? We use the x dx. We use this property. Now x varies from minus 5 to minus 2. So we'll take any value in between. We'll take minus 4. Put minus 4 plus 2 is minus 2. We get a negative value, but you should get positive value. How to get it? Add a negative sign. Minus 5 to minus 2 minus of x plus 2 dx. Now if we take x is minus 4 plus 2 minus 2 into minus is plus. So getting this, we have removed this modulus here, plus minus 2 to 5, take any value in between, put 0, so 2, so positive value you're getting. So we can write this as such, x plus 2 dx. Now this minus sign is there, minus sign will take it outside, then integral minus 5 to minus. Because minus sign is there here, I am putting minus, again putting a bracket. If we integrate x with respect to x, what will come? X square by 2 plus this, on integrating this will become 2x, then we have to put minus 5 to minus 2. On integrating x, we will get x square by 2, again 2x, here varies from minus 2 to 5. Now this minus sign is there. For x, we will put the upper limit minus 2. X is minus 2, x square is 4, 4 by 2 is 2. So we will write 2 plus x is minus 2. So it will become minus 4. Then minus, now we have to substitute the lower limit. For x you put minus 5. X square is 25. So it will be 25 by 2. Again for x minus 5, so minus 10. So this plus for x you put 5, so it will be 25 by 2 plus 2 into 5, 10. minus, you put lower limit, minus 2 whole square is 4, 4 by 2, 2, then 2 into minus 2 is minus 4, minus of 2, 8, minus 20, 25 by 2, answer. We have to evaluate this integral. Now you may be knowing how to proceed now. We have to proceed same way what we had done earlier. What we have to do now? We have to equate x minus 5 to 0. So x minus, now we can write the integral as sum of two integral 2 to 5 modulus of x minus 5 dx plus 5 to 8 modulus of x minus 5 dx. First step we can write like this. Now we have to take x varies from 2 to 5. You take any value between 2 to 5, you will take 4. So 4 minus 5 is minus 1. So we have to make this positive. So you have to add a negative sign. So 2 to 5 we can write minus of x minus 5 is 5 minus x dx plus, if we put any value, x varies from 5 to 8, put x is 7. 7 minus 5, 2, positive value. So here 5 to 8, x minus 5 dx. Here we can write as such. Now we will integrate. This is 5x minus x square by 2, 2 to 5. X square by 2 minus 5x. Again limit is 5 to 8. Now substitute the upper limit. 5 into 5, 25 minus x square, 25 by 2 minus, now we have to substitute the lower limit. 5 into 2, 10 minus 2 square, 4 by 2 is 2. This plus, again for x substitute 8, 8 square by 2, 64 by 2 is 32 minus 5 into 8, 40 minus, now you put x is 5, 25 by 2 minus 5 into 5, 25. So 9 is the answer. In this problem, we have to integrate x into 1 minus x power n with respect to x. 1 minus x power n, we have to expand by binomial theorem, we'll get n plus 1 terms, and we'll use the property, that is 0 to a f of x dx is equal to 0 to a f of a minus x dx. Then we can write this as 0 to 1, replacing x by a minus x, a is 1 here, so that is 1 minus x then dx. One minus x is replaced by 1 minus x. Now this becomes integral 0 to 1, 1 minus x. Here 1 minus 1 plus x. So this will become simply x power n dx. Now this is here. So integral 0 to 1 x power n minus x power n plus 1 dx integral x power 1 dx is what? X power n plus 1 by n plus 1. This will be x power n plus 1 plus 1, that is n plus 2 by n plus 2, then 0 to 1. Now put x is 1. So 1 by n plus 1 minus 1 by n plus 2. You put x as 0, both terms becomes 0. So now we can take n plus 1 into n plus 2. So this becomes n plus 2 minus of n plus 1. So 2 minus 1. So this will be 1 by n plus 1 into n plus 2. So this is the answer. In this problem, we have to evaluate in the log of 1 plus tan x dx, and limit varies from 0 to pi by 4. Again, we will use this property. Then what will come now? Here a is pi by 4 and f of x is log of 1 plus tan x. And we have to replace x by a minus x, that is a is pi by 4 minus x. So you can write this as 0 to pi by 4 log of 1 plus tan of x is what now? We have to replace x by a minus x, that is a is pi by 4 minus x. Dx using this property. Now what comes now? 0 to pi by 4 log of 1 plus tan of pi by 4 minus x is what now? So you should know the formula tan of a minus b. Tan of a minus b is tan a minus tan b by 1 plus tan a tan b. Tan a, tan 45 minus tan x by 1 plus tan 45 tan x dx. Tan of a minus b is tan a minus tan b by 1 plus tan a tan b. Tan 45 is 1. So this we can write as 1 plus 1 minus tan x by 1 plus tan x dx. Now we will take the LCM. 1 plus tan x plus 1 minus tan x by 1 plus tan x dx. One plus 2 gives, this is 1 and this is 2. 1 plus 2 gives 2i, I plus I. 2i is equal to the 0 to pi by 4 log of 1 plus tan x dx plus 0 to pi by 4 log of 2 by 1 plus tan x dx. What we can do now? See the form log m plus log n. What is log m plus log n? Log mn. So we can write this as 0 to pi by 4 log of m. This is n, mn. So that means 1 plus tan x into 2 by 1 plus tan x dx. Using the property log m plus log n is equal to log of mn. Now this is equal to 0 to pi by 4. Will get cancelled and we are left with the log 2 dx. Log 2 is constant, so you can take log 2 outside. Integral 0 to pi by 4 dx. Now on integrating this, you will get a x 0 to pi by 4. So x is pi by 4 minus 0, so pi by 4 log 2. This is equal to 2i. You should not say this answer. This 2i is equal to this value. So this implies I is equal to pi by 8 log 2. So what we got is 2i. So I is equal to pi by 8 log 2. So this one. Use the same property 0 to a f of x dx is equal to 0 to a f of m minus x dx. So that means this is equal to 0 to 2 minus x. Wherever x is there, we have to replace by 2 minus x. Then the square root of 2 minus this we have to replace by 2 minus x dx. Using the property, now this reduces to 0 to 2 minus x, 2 minus 2 plus x. So this will become x power half dx. I will multiply 2 into x power half minus x power 3 by 2 dx. If we integrate x power 1 by 2 with respect to x, what we will get? X power 1 by 2 plus 1, that is x power 3 by 2 by 3 by 2, because this 2 is here, minus this will be x power 3 by 2 plus 1, 5 by 2 by 5 by 2, then 0 to 2. So before substituting the value, we'll simplify this expression. So this will be 4 by 3 x power 3 by 2 minus this will be 2 by 5 x power 5 by 2, 0 to 2. Now for x I will put upper limit to 2. So 4 by 3 into 2 power 3 by 2 minus 2 by 5, 2 power 5 by 2. Minus lower limit to put x as 0, that will become 0. Now 4 by 3, 2 power 3 by 2 is nothing but 1 plus a half. So we can write this as 2 root 2 minus 2 by 5, 2 power 5 by 2. So we can write 4 by 2 is 2, 2 plus half. 5 by 2 we can write as 2 plus half. So 2 square is 4. So we can write this as 4 root 2. So this becomes 4 root 2, this becomes 2 root 2. So So 16 root 2 by 15. So this is the answer. So we have to evaluate this integral. Again we will be using this property and see what happens. So this is equal to 0 to 5 by 2, 2 log of, we have to replace x by pi by 2 minus x, a is pi by 2 here. So log of sine of pi by 2 minus x minus log of sine of 2 times pi by 2 minus x dx. Sin 90 minus x is cos x. So this will become 2 log of cos x minus log of sin of 180 minus 2x. 180 sin of pi minus 2x. What is sin of 180 minus theta? That is sin theta itself. So it will be sin 2x itself. Now we will take this as 2. Now add 1 and 2. 2i is equal to 0 to pi by 2, 2 log of sin x minus log of sin 2x plus 2 log of cos x minus log of sin 2x dx. So the limits are same, dx is there, I just added these two terms. Now 0 to pi by 2 log of sin 2x minus log of sin 2x, this will become 2 times log of sin 2x like that. So this 2 log will take 2 outside. In these two, if we take 2 outside, then what will come? Log of sin x plus log of cos x. Then this will be minus 2 times log of sin 2x. Now in this term 2 is there, in this term also 2 is there, so we will take 2 outside. When you take 2 outside, 0 to pi by 2 log of, again what is log m plus log n? Log mn. So this will become log of sin x into cos x minus, we have taken 2 outside already, log of sin 2x. So this two we taken outside here. 0 to pi by 2 log m plus log n is log mn minus log sine 2x. These two has come here already. Now 2i is equal to 2 times integral 0 to pi by 2. You see log m minus log n. What will come? Log m, this is m, minus log, this is n. Log m minus log n is log m by n. So this will be log of m sin x into cos x by sin 2x dx. So this implies I is equal to 0 to pi by 2 log of what the value of sin x cos x by sin 2x. Sin 2x we can write as 2 sin x cos x dx. So this reduces to 0 to pi by 2 log 1 by 2 dx. So log 1 by 2 will take outside, pi by 2 dx, again log of 1 by 2, this is x pi by 2 only, so we can write this as pi by 2 log of 1 by 2. So this is the answer. This is in the form of integral minus a to plus a f of x dx form. This is in the form of integral 2 times 0 to a f of x dx. When this will become, if f of x is even. Otherwise it is 0 if f of x is odd. And what is f of x here? F of x is sin square x. F of minus x is sin of minus x whole square. F of x is sin square x. F of minus x means in this function wherever x is there, we have to replace x by minus x. So this will be again sin of minus x is minus sin x whole square. So this becomes sin square x only. F of minus x is equal to f of x. So that is the even function. F of x is even function. Therefore, 1 becomes I is equal to 2 times 0 to pi by 2 sin square x dx. What is 2 sin square x? We know that cos 2x is equal to 1 minus 2 sin square x. So 2 sin square x is 1 minus cos 2x. So this will be 0 to pi by 2 1 minus cos 2x with respect to x we will get x and cos 2x if integrate sin 2x by 2, then limit is 0 to pi by 2. Now this is equal to x is pi by 2 minus sine x is pi by 2, 2x means 2 times pi by 2 sine pi by 2 minus of x is 0 sine 0 so answer is pi by 2 because this 0 this everything becomes 0. This is an interesting problem. Again we'll be using property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So when you use that 0 to pi, replace x minus x by pi minus x dx by 1 plus sine of pi minus x using pi minus x by 1 plus sine of 180 minus theta is sine theta itself. So this sine x itself dx adding 1 and 2, 1 plus 2, 2i is equal to 0 to pi, here x, here pi minus x by 1 plus sin x dx. Now how to evaluate integral dx by 1 plus sin x? It's simple. You have to multiply numerator and the denominator by 1 minus sin x. Pi into 0 to pi 1 minus sin x by 1 minus sin square x, that become cos square x. This is 2i. Now how to proceed now? We have to divide the numerator by denominator. 1 by cos square x is secant square x minus sin x by cos x is tan x. 1 by cos x is secant x dx. Now if we integrate secant square x, what will come? Tan x. If we integrate tan x secant x with respect to x is nothing but integral secant x tan x dx. So if we integrate, we will get secant x 0 to pi. So pi into, first to put the value of we know tan 180 is 0, secant 180 is, cos 180 is minus 1, so secant 180 is also minus 1, 1 over minus 1 is minus 1, minus of tan 0 is 0, minus cos 0 is 1, so secant 0 is also 1. Equal to 2 pi, so I value is pi, so this is the answer. What form is this one? This is in the form of integral minus a to plus a f of x dx. In the form of 2 times 0 to a f of x dx if f of x is even function. If it is odd function, that will become 0. Here f of x is what now? Here f of x is sine power 7x and f of minus x sine of minus x power 7 So minus sin x power 7. So this is minus sin x. This is minus sin x power 7. So that means f of minus x is equal to minus f of x. Sin x power 7 is f of x. So therefore f of x is odd function therefore the value of I is equal to 0. So this integral is of the form 0 to 2a f of x dx. What is integral 0 to 2a f of x dx? This is equal to 2 times 0 to a f of x dx when f of 2a minus x is equal to f of x. Here what is f of x? Here f of x is cos x power pi. What is the value of a? 2a is pi. A value is pi, and we have to see f of 2a minus x is equal to what? And then this value is equal to 0 if f of 2a minus x is equal to minus f of x. So we will find f of 2a minus x. F of 2a means 2 pi minus x. So this is nothing but cos 2 pi minus x power 5. So what is cos of 360 minus theta? Cos pi itself, cos x itself. Cos of 2 pi minus x is cos x itself. So pi comes. 2a minus x is equal to f of x is coming. Therefore 1 becomes 2 times 0 to pi cos power pi x dx. Now we have to write the pi as 2 times 0 to 2 times pi by 2 cos pi x dx. Again we have to use the same property 0 to 2a f of x dx. Again we have to find the f of 2a minus x. Here f of x is cos x power pi. A is equal to pi by 2. 0 to 2a is pi by 2. We have to find f of 2a minus x. So f of 2a is pi by 2. 2a is pi minus x. This value we have to find. So f of x is this one. F of pi minus x is wherever x is there, we have to replace x by pi minus x. So cos of pi minus x power 5. What is cos of 180 minus theta? 180 minus theta is in the second quadrant. second quadrant only sine and 1 by sine cosecant. Only those two trigonometric functions have positive value. Therefore, this will have minus cos x power 5. So, minus 1 power 5 is minus cos x power 5. So, this is nothing but f of x minus f of x. F of pi minus x is minus f of x is coming. Therefore, I is equal to 0. Why 0? If f of 2a minus x is equal to minus f of x. Here a is pi by 2, 2a is pi, so f of 2a minus x is equal to minus f of x is coming. So this condition is satisfying, so the value of this integral is 0. So this is the answer. So I is equal to a by 2. So this is the answer. Minus 1, 5. So this is the answer. 1 plus 8, 9. Minus 4, 5. 5 plus 1, 6. 6 minus 1, 5. So this is the answer.